This video is for lesson 5.11 for review packet 5C. Michael joins the Old Barn Book Club. He gets 10% discount on books and CDs. It costs $15 to join the club. And this is built a function machine network using the cost of the books. Michael buys as the input. The output is the total amount he will pay, include the $15 membership fee. Okay, so you make something like this, or here's a machine, and you put it in something in, you put something in, and you put something out, right? So in this machine, what you do is it takes 10% off, but you have to add $15. So the input will be the cost of the books. So for example, the original cost. So for example, if you spend $100, right, then it gives you 10% discount. However, you gotta pay $15. So at the end, how much money you have to pay, right? So here's a hint. 10% discount means you have to pay 90% of it, which is which you can find by multiplying by 0.9, right? So that's A, and B, find the rule for C of D. C of D, that C stands for cost, I believe. It says Michael's cost for buying D dollars worth of books and CDs on the day he joined the club. So C of D, find the rule. What would be the rule, right? So D will be the D dollars, the original dollars. If it's 100, you multiply by 0.9, then add 15. If it's 50, then you multiply by the same amount and add 15. That's the original money. You can find those money like that, right? How much does Michael need to spend to make joining the club worth the $15 cost? So if he only spends, certain amount, he's not going to get the benefit out of being a member because you have to pay $15 first. But generally speaking, the more he spends, the more benefit he gets. Less he spends, the less benefit he gets. That's the whole point of membership, right? So how much money does he really have to spend in order to get the most benefit out of it, right? So that's problem 8. Problem 9, in a 50-50 raffle, half of the collected money goes to the prize and half goes to the charity running the raffle. The charity sells 800 tickets at 75 cents each. The first prize $150. The second prize is $60. There are three third prize. So if he sells, if they sell 800 tickets at 75 cents, if they sell all of them, then how much money do they get, right? So whatever the money, half of it goes to the prize, and half goes to the charity. So whatever the money, half goes to the prize, in which in that half of the money, they give out $150 as a first prize, and the second prize is $60. And then the third prize, whatever the money left, you divide that money by 3 because you have 3 third prize, and that's going to be the amount of money that he has, that the third prize will be, right? So again, half of the collected money. So whatever that is, okay, you got that money, half of it, so divided by 2, right? You get the money, the half of the money. So let's say this is the entire prize. This is the the money that he get, for example, if they sell all of them, right? Half of them, they use the prize as a prize, and half of them goes to the charity. So we don't have to worry about that because that money will be gone. And within this money, they spend $150 for the first prize and $60 for the second prize. And then whatever the money left, right there, you divide it by 3, and those money will be the third prize. So it really depends on how many tickets can sell. So these number changes depending on how many tickets they can sell. The more money, the more tickets they sell, then the higher the third prize will be, right? Obviously, but if they don't sell that much, the third prize is not going to be that much. Okay. And the next problem: Brent and Jill run the Carolina cross country team competition for 2 divisions. So here, I was really misunderstood that. They said run. That run means they don't actually run like a walking, speed of walking. They actually running that competition. So they're the top and they're managing all those competition. So they're actually not running. So and it says, so they have 2 division of that. An entry of the A division costs $10. So whoever register for the A division is $10 and B division is $5. And the Brent says, whoa, we had 195 entries, outstanding. All right, so in total for those A division and B division, in total they got 195 entries. So 195 people will probably do that, right? Will probably run. All right. Now, Jill says, Brent estimates that 80 entries for the A division. If he's correct, how much money did Jill and he collect for the entries? So, if in this A division, there's 80 of them, and in total we have 195, what would be, how many entries will be here? That's a subtraction problem. That's pretty easy. Oh, by the way, Division A, Brent is running, and Division B, Jill is running. So Jill is the top person Jill is in charge of Division B, right? So A is pretty easy. B, Jill says, it turns out we collect $1,525 for entries. That's not bad. How many A division entries were there? Okay, so forget about 80 entries, right? Because that's not the part of it. It turns out we collected. We means we, right? That's not bad. How many A division entries were there? So again, A division cost $10, B division cost $5. And then in total, there's 195 entries. So you can set up some. System of linear equations, right? So for example, well, you can actually guess and check. I want you to do the guess and check. So for example, if there is a division and a B division, if there is 10 people in a division, then it will be 185 people. So for 10 people, those people paid $10, and these people paid $5, right? And if you add these together, that money should be $1,525. Would that total be that money? If not, try another one, 20 and 175. And if it doesn't work, the guess check generalized method, the point is not to get the right answers, to see the structures by doing different, like probably 2 or 3 guesses. You'll start seeing the structures, and then once you start the structures, replace the number with variables and letters to see if, and then just solve it, right? So that's how I would tackle the problem.